Okay, now we're looking at question 1, part C. Okay, so we've got to find the domain and range. So for the domain, that's the permissible values of x. Now we know that a log function can't take 0 or a negative value, so that means that this bit here that goes into the log function must be greater than 0. So we've got x plus 1 must be greater than 0, so therefore x has to be greater than minus 1. And that sort of implies straight away that the vertical asymptote is going to be moved 1 to the left, and this would indicate here a horizontal translation of 1 unit to the left. Okay, the range, well, just finish off here, the domain then equals, and the range is just all values of y. So y is an element, any real number. Alright, asymptotes and axes, intercepts. Well, we'll have a vertical asymptote when x plus 1 is equal to 0. And so that gives us the vertical asymptote x equals minus 1. Now, axes, intercepts, we can look at the x-axis. We know that the y value must be 0 to find the x-axis intercept. So that means solving 1 minus log to base 3 of x plus 1 is equal to 0. Rearranging, that gives us the log to base 3 of x plus 1 is equal to 1. And so that means that x plus 1 is equal to 3 to the 1. And so x must be equal to 2. Alright, I've marked this down here. How did I get this line from here? Well, I've sort of explained that up here. That's where that came from, using this law here, which is used all the time. Alright, this one I'll have a y-axis intercept as well. We know that the y-axis intercept occurs when x is equal to 0. So we substitute and we get y will be equal to 1 minus log to base 3 of 0 plus 1, which is 1 minus the log to base 3 of 1. And of course the log to base 3 of 1 is just 0, so that's 1 minus 0, which is 1. So the y-axis intercept is at 0, 1. Now, how did I know there would be a y-axis intercept? Well, if the vertical asymptote is at x equals minus 1, and the graph is going to be wholly to the right, then it follows to reason that it's going to cross the y-axis. Now, over here I've circled, how did I know that the log of 1 to base 3 was equal to 0? Well, that's explained over here. The log of 1 to base 3 is the same as the log, shouldn't have those two equals there, of 3 to the 0 to base 3, which is 0, using this law here. Again, that's one of those other two, the law on the previous page and that one come up all the time. Alright, part 3 now we need to sketch the graph. Got some axes over here. Okay, from part 2 we've got a vertical asymptote at x equals minus 1, so we'll sketch that in. We've got an x-axis intercept at 2, 0, so mark that. We've got a y-axis intercept at 0, 1, mark that on. Now let's look at the translations in this. Y equals 1 minus log x plus 1. Our normal log curve would look like that. We know though we've got a horizontal translation 1 unit to the left, so that moved our vertical asymptote over there. Then we've got this minus up here. So that's going to reflect this into the x-axis. What's positive will be negative, what's negative will be positive. So it's going to be coming down that way. And then we've got a vertical translation due to this of +1, so it's going to be shifted up 1. So we're going to have something that looks like this, coming down that way like that. So sketching that in now on our proper axes, it should look something like this. Alright, part 4, solve for fx equals -1. I'm going to try to squeeze this in down the bottom here. Maybe I'll do it in a different colour. Right, I've chosen a different colour, so maybe I can find somewhere to fit it in. We want to solve for 1 minus log to base 3 of x plus 1 is equal to -1. I'm finding that hard to see, just give me a minute. Alright, change colour there, that's a bit easy to see. So rearranging that, we get the log of x plus 1 in base 3 is going to be equal to 2. So that gives us x plus 1 is equal to 3 squared, which is 9. So therefore x must be equal to 8. And so across 1, 2, 3, 4, 5, 6, 7, over here it's got to be passing through this point over here. Extend our axes and the graph comes through there, through the point 8 minus 1.